Okay guys, let's have a look at question 9 then. We've got sine x, which I've drawn already. It's easy to draw. Sine 2x and sine 3x. Well, what happens here then? Well, let's have a look at that, shall we? The sine x value, at 90 we get 1, don't we, when we put 90 in here. If we put 45 in here, we'll get the 90 value outputted, which is 1. So that output value happens in this function when x is 45. So that goes there. And when it's 90, two 90s are 180. Sine 180 is 0. So basically, this whole thing is going to be squashed into this part here. Okay, so we can draw that now. There we are. And then that's the sine, that's that one. Now what happens here? Say at 135, which is halfway between, isn't it? Two 135s are 270, you get minus 1. So here, it would be minus 1, and then 180, 2 lots of 180 is 360, it would be 0. So can you see what happens? It goes down and up. So instead of it going up and down in 180 and down and up in 180, it goes up and down in half as much, 90, and down and up in half as much, 90. So that same sort of pattern continues then. So here it should go up and down in 90 again, because it just repeats. So it's up and down. And then it should go down and up, shouldn't it? In the next 90. So there we are. There's our sine 2x. Now let's draw sine 3x and see what happens to this one. So the 90 occurs when x is 30. So it happens at 30. So it goes up and down. When x is 60, 360s are 180. So there's 30, there's 60. So it goes up at 30, down at 60. Yeah, agreed? So it goes up and down. And then that was 60. At 90, 3 90s are 270, it has the value minus 1. And then at 120, 3 120s are 360, it has the value 0. Okay, so it's going to go down and up. So can you see every 60 degrees it's going to go either up and down or down or up. So here's another 60. So it's going to go up and down here, isn't it? So in between there's 150. Okay, so it goes up and down, doesn't it? And then the next one, it goes, oh, I better do that again because I'm not happy with that. Let's just go up and down. And then down and up. In the next 60, which takes us to 240. So at 210, it's going to go halfway between, it's going to go down and up. Yeah? Nope, 240 I said. So let's just do that. I've marked it off so it goes down and up. Okay, and then another 60. So that's 240, so to 300. And at 270 it must go to the top and down, and then the last one is down and up, 330, wouldn't it? It goes down and up. There we are, bit of a squash, I know. Let's have a look at it on the actual plot, shall we? Good. Okay, here's the plot then. I've typed it in, sine x, sine 2x, 2 times x, and sine 3 times x. Let's generate the curve. Let's see if we get the same sort of thing. Yeah, see it? Here's the normal sine curve, that blue one, and then the sine 2x. So instead of going up and down in 180 pi, it goes up and down in 90, half as much, then down and up in 90, up and down in 90, down and up in 90. So that's the sine 2x. The sine 3x, well, instead of going up and down in 180, it goes up and down in 60, doesn't it? 3 times as fast. And then down and up, and another 60. And then up and down. That would make 180. Then that one would be 240, 300, and then up to 360. And that's sine 3x. So yeah, everything's fine. It just concertinas, the bigger the x is, the more concertina the sine function would be. Okay, that's that one done then. Great, let's go on to the next question.